Hey everyone, and welcome back to the channel. Imagine you are running a super busy online store with millions of customers. Each customer record holds a ton of information from their basic name and email all the way to really access details like maybe the obscure user preference or maybe historical data. Now, when your system has to retrieve data quickly for millions of users, it can really struggle. Why? Because every single query has to sift through all this extra package. Columns, basically, we have and the extra package are just columns. It often doesn't even need to be retrieved. This is where a powerful database design technique called vertical partition comes into play. In this video, we will explore exactly what vertical scaling is, why it is so important for large scale systems, how it works, and most importantly, when and how to apply it effectively. Okay, so let's talk about first what is exactly vertical partitioning. So vertical partitioning is a database design technique that involves splitting a single large table into multiple smaller tables, but unlike horizontal partitioning, which divides data by rows, for example, splitting customers ID by region, for example, vertical partitioning divides data by columns. For example, if you can see this example here, we have a table, we have a key, name, description, stock, price, and date, and we will divide this table into two tables. And we will put in one table the common information that the queries often ask about. For example, the name, description, and the price. And then the other values which are less queried, or let's say the queried is not built on top of them that much as the other table, it will be put in its own table. Okay, why this is powerful? Again, we will have a table. We just take all the frequently queried values or the frequently queried columns, we put them in one table, and the other table, which is less frequently queried, we put them in another table. Why this is important? Why should we consider this? Okay, first, this provides faster query. Like when your queries only need to access a subset of columns, they have significantly less data to scan. This directly translates to faster response times and a smoother user experience. Number two, we reduce the I/O overhead by intelligently storing frequently accessed what we call hot columns. For example, we separately when we store them separately from rarely used columns or cold columns, you dramatically reduce the amount of data the database needs to read from the disk. Less disk I/O means faster operations. Next, we have improved cache efficiency. Smaller, more focused tables, which contain only the most frequently accessed data, can be more effectively cached in memory. This means that your application needs most often is more likely to be in fast RAM, further speeding up read operations. Also, it provides some sort of better scalability. Like when tables become too wide, meaning they have an excessive number of columns, they can become cumbersome to manage and scale. Vertical partitioning breaks them down into more manageable pieces, making future scaling efforts quite easier. And number 5, 1, 2, 3, 4, 5. Yeah, optimized storage tiers. This is fantastic benefit for cost management. The columns that are rarely updated or accessed, such as historical notes or large binary objects, can potentially be stored on slower, more cost-effective storage tiers. Meaning, while your frequently updated or critical columns can reside on faster one, more expensive storage, giving you quite flexibility. And lastly, we have efficient indexing. Indexes built on a smaller set of columns are generally faster to build, faster to traverse, and require less storage space themselves. This means your indexing strategy become more efficient overall. Okay, when to consider vertical partitioning. First, if you have a white column, white tables, the most obvious sign is when you have a single table with a very large number of columns, especially if not all of these columns are consistently used in every query. Number two, diverse access pattern. If different parts of your application or different modules consistently need different subset of the data from a single large table, vertical partitioning can tailor the data access. Number three, we have performance bottlenecks. If you are experiencing suffering read performance and profiling indicates that scanning irrelevant columns is a major overhead, then vertical partitioning is a strong candidate for optimization. Sorry. Okay, how to apply it? First, you need to identify column usage patterns. The first crucial step is to analyze your application's queries. Use database monitoring and query analysis tools to understand which columns are accessed together frequently and which are rarely used. This data-driven approach ensures you are partitioning effectively. Number two, group columns logically. Based on your analysis, divide your original tables columns into logical groups. Typically, you will create one group for frequently accessed or hot data and one or more groups for infrequently accessed or cold data. Number three, create a separate tables. If we take our previous example, we have like we are physically creating new tables for each of these logical groups for our, I don't know, for this is a stock price or a customer, something like that. So we might put the name, the description, the price, and this would be like a hot table, or these are a hot columns. So we put them in a table, and we have other tables. So that are quite cold. They are not accessed that frequent. So we put them in this table. Okay. Next, we ensure a common key. Like, it's absolutely essential that each of your newly partitioned tables shares a common primary key. In our example here, if you want to see, we have here the key. Oh, okay, so it should be, we have the same key. It should be the same key because we need to, it will make the join process easier to do. Okay, I would say number 5, which is to update application logic. Like, finally, you will need to modify your application queries and data access layers to fetch data from the appropriate tables. I guess many modern ORMs, which is object relational mappers, or even database views, can help abstract these details, making the transition smoother and preventing widespread code changes. Okay, let's talk about some challenges and trade-offs. So while vertical partitioning offers many, let me just say it in the right way. While it offers many compiling benefits, it's not without its challenges and the trade-offs. The first thing, we have increased complexity in queries. Like, when you need to retrieve data that spans across your newly partitioned tables, you will partition tables, not tabled. You will now require to use join operations. If these joins are not optimized properly, they can introduce their own overhead and negate some of the performance benefits you gained. Number 2, we have data consistency. Maintaining data synchronizations and consistency across partition tables requires careful management, especially when you are performing updates or deletion that affect the columns in multiple partitions. Number 3, we have a problem with application changes. Implementing vertical partitioning often means that existing applications will need to be refactored. Your data access layers, I guess, and SQL queries might need to be written to accommodate the new schema, which can be quite significant development effort. Number four, not three. Number four, maintenance overhead. More tables mean more databases, objects to manage, backup, and monitor. Your database administration task might become slightly more complex. Okay, let's talk about some best practices. So first, you need to analyze query patterns religiously. Like, don't guess. Use your database monitoring and query analyze tools to get real data on which columns are accessed together and how frequently. This data should drive your partitioning decision. Number two, start small. Don't try to partition your entire database at once. Consider applying this strategy only to the most problematic performance bottleneck tables first. Prove the concept and benefits before expanding it. Number three, utilize database views. Create database views to abstract the partitioning details from your application logic. Your application can then query the view as if it were a single table, and the view will handle the underlying joins to the partition tables. This makes maintenance and future changes way more easier. And lastly, we have test technology, test thoroughly. So before fully deploying vertical partitioning in your production environment, conduct a rigorous testing, evaluate its impact on query performance for both simple and complex queries, and thoroughly verify data consistency in a staging environment. Okay, that was a good video and a quick video in my opinion. So in conclusion, vertical partitioning is a powerful strategy in system design that directly helps manage white tables and significantly improve database performance by splitting data into more manageable, focused pieces by strategically grouping columns based on their access patterns. You can effectively reduce query latency, optimize your storage costs, and enhance the overall scalability of your system. While it does introduce some architectural and query complexity, its benefits often far outweigh these challenges. So yeah, that's it for this video. If you like this video, give it a like, subscribe, and hit the notification bell so you'll never miss any video, and see you guys in future videos.